Hello and welcome. In this video, I want to help you how to factor a quadratic when your a value is equal to 1. Before I begin to show you some examples, I want to take some time and map out this entire factoring process. We begin with a trinomial of the form ax squared plus bx plus c, and we know it's quadratic because the highest exponent of our variable is going to be a 2. For this set of examples, a is going to equal 1, b and c are real numbers. Because a is equal to 1, we can reduce this generic form into x squared plus bx plus c, since 1 times x squared is going to give us x squared. The objective of this factoring process is to rewrite this trinomial into the product of two binomials, something along these lines. And to do so, we need to find two numbers that when you multiply them together, they're going to give you the value for c, but if you add them, they will give you the value of b. As I begin to illustrate this process with some examples, I will be making use of an X diagram. And this X diagram is a very popular method of organizing your key terms and helpful in identifying the numbers needed to multiply to c but add to b. So let's get started with example number 1. We have the trinomial x squared plus 10x plus 24, and the instructions are to factor. Now, in any factoring problem, the first thing to do is to check and see if we can factor out anything other than 1. And after some inspection, we conclude that we cannot. These numbers don't share any factor other than 1, so I will begin to approach this problem by labeling my key terms. My a value is going to be 1, my b value is going to be 10, and my c value is going to be 24. Since I realized that my leading coefficient has a value of 1, I can apply this X diagram, where I can make use of this X diagram to keep track of my organization that will ultimately help me identify the two numbers that multiply to c but add to b. So here, let me apply this to this specific example, recording my c value on the top, that's 24, and recording my b value on the bottom, that's 10. And now I need to find these two numbers. I'll admit that there is a component of trial and error, but as you continue to practice, you'll develop experience, and this process will go by a lot quicker. In the meantime, if you're having a difficulty finding these two numbers, here's what I suggest. Grab the value of c, in this case it's the 24, and we're going to do a little bit of side work. We're going to begin to brainstorm factor pairs, and then after we have 4 or 5, we're going to begin adding them and checking to see if we found one that adds to 10. So here's what I mean. I know that 1 times 24 gives me 24. I know that 8 times 3 gives me 24. 6 times 4. And 12 times 2. Again, once I have 4 or 5, that's a good place to start. So I'm going to begin to add them in hopes of getting a 10. So 1 plus 24 gives us 25, so this pair doesn't work. 8 plus 3 gives us 11, so this pair doesn't work either. And then the 6 and the 4, that one adds to 10. So this is the pair that I need. And I've found the two numbers that if I multiply together will give me the value of c, in this example the 24, but if I add them, they'll give me the value of b. In this example, it's 10. Once you've identified the pair that multiply to the value for c and add to the value for b, you can rewrite the trinomial as the product of the two factors. In this case, x plus 6 multiplied by x plus 4. And because of the commutative property of multiplication, I want to note that you can also write the expression as x plus 4 multiplied by x plus 6. Both of these mean the exact same thing. Let's move on to another example. Example 2, we have the trinomial x squared minus 15x minus 100. We first check to see if we can factor out anything other than 1, and after some inspection, we conclude that we cannot. So I'll begin by labeling all of my key terms. My a value is 1, my b value is negative 15, and my c value is negative 100. Because my leading coefficient is 1, I can make use of the X diagram to help me organize my values and help me identify the factor pair that multiply to C but add to B. Applying it to my specific example, on the top I'm going to record the negative 100, and on the bottom I'm going to record the negative 15. So I need to find two numbers that multiply to negative 100 but add to negative 15. I grab my C term and I'm going to begin to do some side work by brainstorming factor pairs. Because I have a negative number, notice that I'm going to have to be using values that are negative. So here I can begin with 10 times negative 10, 20 times negative 5, and actually you can also play around with the signs. So for this one, we can count negative 20 times positive 5 as a different pair. Let's do one more, 1 times negative 100. Now I'm going to check and see if I found one that adds to negative 15. So here, 10 plus negative 10 gives me 0, so this one does not work. 20 plus negative 5 gives me a positive 15, but I need a negative 15. The negative 20 plus the 5 gives me negative 15, and this is the pair that I need. Negative 20 multiplied by 5 give me the negative 100, but if I add them, I get the negative 15. Hence, I can rewrite this trinomial as the expression of two binomials, x minus 20 multiplied by x plus 5. I'd like to look at one more example, example 3. Here we have 2x squared minus 22x plus 48. In any factoring problem, the first thing that we always want to check and see is if we can factor out anything other than 1. In this case, notice that the 22, and the 48 all share a greatest common factor of 2. So I'm going to begin by first factoring out that 2. And we can rewrite this expression as 2 multiplied by, and to find out what goes inside of the parentheses, we just divide each term by whatever it is that we factored. Beginning with the 2x squared divided by 2 will leave us with an x squared. Negative 22x divided by 2 is going to leave us with a negative 11x. And lastly, the positive 48 divided by the 2 is going to leave us with the positive 24. Zooming in on the parentheses, we now have a trinomial x squared minus 11x plus 24. And notice that the leading coefficient is 1. If I label the rest of my key terms, we can see that the b value is going to be negative 11 and the c value is going to be 24. Because the leading coefficient is 1, we can apply the x diagram for organizational purposes, and this is going to help us identify the two numbers that multiply to c but add to b. So let's go ahead and fill that up. My c value is 24 and my b value is negative 11. I need to find two numbers that multiply to 24 but add to negative 11. I'm going to do some side work by grabbing the 24 and brainstorming factor pairs. So I know that 2 times 12 gives me a 24. And notice that we have a negative 11. We need to add to a negative 11. So the positive combinations are not going to work. So I need to make use of the fact that a negative times a negative is a positive. So brainstorming possibilities with negatives, we have negative 8 times negative 3, and let's do negative 2 times negative 12. Let's check and see if one of these pairs adds to negative 11. If none of these add to negative 11, we have to continue with the brainstorming process. So beginning with the 2 and the 12, 2 plus 12 is 14. This does not work. Negative 8 plus negative 3 gives us the negative 11. And this is the pair that we need. To finish the factorization, we need to rewrite the trinomial as the product of x minus 8 and x minus 3. We cannot forget to include that 2 since that's what we originally factored. So we're going to write this as 2 multiplied by x minus 8 multiplied by x minus 3. And that would be the final factorization. Now would be a good time for you to practice. So I encourage you to try these huge try problems. These solutions will present themselves in 3, 2, 1. Thank you for watching. I'll see you next time.